Welcome to the channel Engineering Updates. So in this video, we are going to discuss about the procedure to locate the centroid for any given cross section. So as you can see in today's video, we are going to find out the centroid for the following T section, which has web dimension 200 mm into 10 mm and flange of dimension 100 mm into 10 mm. So to locate the centroid, first we have to identify the flange as well as the web, okay, which you can see from the diagram. So after identifying the flanges and webs, we are going to first locate a reference axis for calculating the centroid. And this reference axis usually will be at the bottom of the section as well as to the leftmost part of the section. So you can see from the diagram, X reference is at the bottom and Y reference is at the leftmost part of the cross section. So now we have the formula to calculate centroid as x bar is equal to summation a into x by summation a, and y bar is equal to summation a into y divided by summation of a. And we have two sections in our T section. So we need to just rewrite the expression or expand the expression as x bar is equal to a1 x1 plus a2 x2 by a1 plus a2, and y bar will be a1 y1 plus a2 y2 divided by a1 plus a2. If there are more sections, then you have to add the corresponding area and xy distance accordingly. So here the web will act as section 1 as well as the flange will act as the section number 2. So to begin with, I'm going to consider only the section 1 and I'm going to find out the area A1, X1 and Y1. So to first locate the centroid of the section 1, which will be as indicated in the blue X mark, and the area for the section 1 can be taken from the dimensions of 200 mm into 10 mm, which will be 2000, and the X1 bar is nothing but the distance of the centroid for the section 1 from the Y reference axis, and which is indicated as 100 by 2, which is nothing but 50 mm will be our x1. Similarly, y1 will be the distance of the centroid from our x reference axis, which is nothing but 200 mm divided by 2. So usually the centroid for a rectangular cross section will lie at the midpoint of the corresponding dimension. So now we have a1 as 2000, x1 as 50 mm, and y1 as 100 mm. So similarly, we will take the section 2 and find out A2, X2 and Y2. The centroid will be lying as indicated in the blue X mark, and the area of the second cross section will be 100 mm into 10 mm, which will be nothing but 1000. And the X2 bar will be the distance of the centroid for section number 2 from our reference y-axis, which is again 100 by 2, 50 mm. Whereas now you can see the distance of the centroid from the y reference axis will give you y2, which is nothing but 10 by 2 plus 200. So 10 by 2 is going to be the centroid of the section 2 with respect to its own axis, and the reference axis, x reference axis, does not coincide with the member. So we are just going to add the distance of 200 mm to the centroid distance. So y2 will be 205 mm. So after finding all the values, simply we are going to substitute in our x bar and y bar. So we know x bar is equal to a1 x1 plus a2 x2 by a1 plus a2. And you just substitute a1 as 2000, x1 as 50, x2 as 50, and the corresponding area 2000 plus 1000. So upon simplification, you will get x bar as 50 mm. That means the centroid for the entire T section is lying at a distance of 50 mm from the y reference axis. So similarly, you substitute the value for y bar. We have a1 2000, y1 as 100, a2 as 1000, and y2 as 205. You just do the math and simplification will give you the value of y bar as 135 mm, which means the centroid of the entire T cross section lies at a distance of 135 mm from the x reference axis. So having found the values of x bar and y bar, I'm just going to locate this centroid for the entire T cross section, which is now indicated in the X cross. So from this, we know the neutral axis for the cross section will pass through the centroid for the entire cross section. So having found that X bar is equal to 50, as you can see, and Y bar is equal to 135 from the lowermost part. So this diagram actually shows the centroid location from different parts of the cross section. So this is the location of the centroid for the entire T cross section. Thank you all. In next video, we will just discuss how to find the moment of inertia about different axes for the same T section. Thank you all.